Hello, and welcome to Adventures in Mechanical Keyboards and episode 206 of Quarkus Insights. We're going to be talking about WebAssembly and how it's quite a cool addition to your Java and Quarkus apps. And so we've got Andrea and Hiram with us. So welcome. I guess to start, so whose keyboard was it, first of all?
Mine. Sorry.
That's okay. So I guess to start, shall we do some introductions? Actually, before we do introductions, have we got any news?
Usually it's just more releases. I'm trying to think of anything specific. No, I don't. I'm drawing a blank. I'm too much of things.
Nope. Yeah, I think we had a whole bunch of minors released last week, which was cool.
Yeah. This is going to be a running joke for the last 3 insights. It's like, and then there's some issues around the test class loader, but that's about it.
I fixed so many.
Yes.
And keep the reports coming in.
Yeah. So no, otherwise things are looking good. Things are chugging along. So
So let's do introductions.
Yes.
Do you want to go first, Andrea?
Yes, I can go first. So I'm Andrea Peruffo. I work for Red Hat as an engineer, and lately I'm very busy into trying to bring WASM on the JVM.
And I'm Hiram Chirino, also a Red Hat engineer. Andrea just drew me into his whole WASM world, and I've been seeing what we can use it for. Basically been working on a little Proxy-WASM implementation for Java. So that's how.
Cool. You got sort of sucked in, and then you discovered there was no escape.
Well, let's kick it off. So what is JASM? What is WASM, and why should I care? Good question.
So I think I can take it. WASM per se is a binary format for executable programs. So nothing fancy. So just a binary format for describing programs and how they run. The cool part is the fact that WebAssembly has been built and to be cross-compatible with almost everything, because it should run in the browser, and that's a superpower, because everyone is targeting WebAssembly to actually run everywhere their own programs. And this is a superpower, because this enables you to write C, Rust, Dart, Go programs and actually run them from wherever host you prefer. Is it the browser? Fine. Is it a Rust program? Fine as well. And now it's available even in Java. So you can run within the safety of the JVM without leaving the observability and invoking native libraries from the JVM. You can directly access those libraries written in foreign languages and run them safely within your application.
So back in the mists of time, Java, a language you may know, was also designed with the promise, or certainly there was the promise of like, hey, Java, you can run it in the browser and you can have applets. And then we fairly rapidly decided that wasn't a good idea. So what's different with WASM?
The difference is that Java failed basically because of security. So applets bring to the browser a lot of security issues when trying to escape. When trying to do real-world applications in Java and deploy them on the browser, you have the need to access a lot of system resources. And this is completely tackled by WebAssembly, because you don't have access to nothing out of the box. So out of the box, WebAssembly is a very, very nice and shiny calculator that can only compute things inside his world. And you give granular access to any resource, CPU, memory, but even access to the network, access to socket or file system, very specifically. So you are very safe about what you're running, and WebAssembly won't fail in the same way, at least not in the same way as Java applets have failed. And remember, Java applet was not a standard, was pushed by one company. Instead, here we are talking about already a consortium of companies that are collaborating toward writing a new standard.
And so the important thing here is it's not just running an arbitrary, it's basically running as like WASM is a sandbox architecture, right? Like the stuff you have to do. And can you explain, because this, I think people misses this because when WASM came out and you can run anything, you can run any Python on it, you know, any Go. But what I realized is that's not true. It's a variant of Go and a variant of Python, right? Like it's like, or can you run any Python on a WASM? Because
how you run Python is actually a super interesting subject, because you don't compile Python. Python is an interpreted language, so you don't take Python and compile it to WASM directly. You take Python as strings, and what we compile is a C Python to WebAssembly. So we run the interpreter inside WebAssembly so that it can take strings with your code in it and interpret and run it. So is effectively the very same C Python as you are running on the host machine. Has no difference, and is since the latest 3.13 release of Python is released as a second tier target architecture. So it is tested, and it will block a release if something goes wrong or doesn't work in WebAssembly.
Yeah, but I'm talking about here, like all the libraries, I assume, is not available in all WASM. Like you like a lot of Python depends on external dependencies, which might not be available in WASM.
That's correct. So if you're a Python program as to connect with some system libraries and invoke them, like NumPy with C++, etc., what you need is to compile it all together into the WASM blob so that it can be actually invoked.
Yeah. Right. So it's not a magical wand. Like there is some extra effort you have to do.
Yes.
Do it. Well, how about Go? Go is a fully compiled language. I assume can all of Go run on in a WASM runtime?
Yes, as there are a few limitations at the moment. Like WebAssembly runs on a single thread. There is one proposal for a multi-thread that is actually around atomics and locks, which just enable running multi-threaded application on WebAssembly, but doesn't help you into spawning new threads. And there are new proposals coming up for adding multi-threading to WebAssembly applications, but this is not part of the standard. So at the moment, running something heavily parallel that takes advantage of those constructs on WebAssembly is going to be slow. So this is and is actually more challenging to compile and actually run there.
Cool. But let's focus on and I guess for Java we have the same limit. Like lots of applications in Java is multi-threaded. There's garbage collection, that stuff. I was trying to get to the point that they all rely on there being some binding from that language. Oh, sorry, my phone is calling. They all rely on there being some bindings that you somehow can represent that SDK or libraries in WASM. Right? And I guess that's why we don't have Java as a WASM runnable right now.
I think the biggest thing is Java's going to need multi-threaded support so that your host can start up multiple threads in the Java environment, and it needs to garbage collect all that memory. So it needs, like, Java's going to need assistance about those things. And once you have those things, I think it's going to be easier to run Java inside WASM.
Yeah. So one thing I'm hoping is that because like when I stand from the Go, right? Like in Go, you have the same thing. You have to limit single-threaded Go application is fine, but multi-threaded is problematic. And in Quarkus, we actually have a lot of our libraries are reactive implemented and could run on a single thread. So I'm just curious of what we actually could do.
I think if you squint at it right, it could run a single thread. I don't think I don't know. I don't believe that. I think that you're going to find out that like a billion libraries out there spawn off a thread in like a pool.
Oh yeah, no,
working. You know what I mean?
But this is the fun thing, like with virtual threads. Like a lot of libraries will fail on that because they're not used to that kind of level. It's a similar.
I do think that in the future, once virtual threads becomes the standard for Java, like everybody's expected to be able to run on virtual threads. I think that world now becomes closer to what like Rust is doing, and we can get it all running on one thread.
Yeah, and that's what I'm saying is that parts of Quarkus is actually implemented in a way that it could run. Not everything, but some workloads you could. So we had because that's what, like, if you look at like Node, same thing. Their apps runs on single threads, and you actually have to run multiple processes to do parallel thing. And a lot of one of the reasons why like some have been discussed, could we do the same thing for Java, because then there's some advantages, and we have a prototype in Quarkus to do that. But yeah, it hits limits, and soon as we get outside, then it's there. But so anyway, cool. But so our focus is not so much about.
Yeah, we've got our first question about virtual threads. Does virtual threads help having multi-threading for IO-bound applications in WASM?
Well, it depends on how you consider help. We have still to implement multi-threading support in WASM at all, and it should be standardized. As soon as we have it, we can probably implement both hard threads and multi-threading on top. That's probably the path ahead.
Thanks. Sorry, Max.
Yeah, no. So I was just trying to head towards it, that our main interest in WASM at this conversation is less about like running Java apps on WASM, even though I think it'll be really fun and useful. Like for example, my favorite one is like Cloudflare has this whole deployment of WASM things. I would love to be able to write Java there instead of writing. I think right now it's have a JavaScript app, and it's just like
but you're touching actually a super interesting point, Max, because you are talking about CDNs, and with the fact that Akamai is collaborating with Fermion, all the major CDN provider in the world are giving you the possibility to run WebAssembly workloads on the edge. That's the use case that really wins everywhere, and that the world is convinced is a good idea, because WebAssembly is extremely lightweight, so you don't need an infrastructure like Kubernetes or whatever to run a full-blown containers, and you just run your application using using the minimal number of resources that you can.
Yeah, exactly right. So, but anyway, we're not going to get there with Java now. You can with Go and JavaScript, that kind of thing. So you're flipping around and being like, hey, there are some ways you can get to access Go and Python and other stuff. And WASM is one of them from Java. So I guess it's the WASM plugin use case that goes. So yeah. So can you explain what are the things that you've been exploring in that aspect?
Yes. So let me share my screen. Maybe I can show you one of the first things that I've been exploring is how to use actually relevant libraries from Java. And this is a demo that is using Quarkus JDBC SQLite 4J. And SQLite 4J is a new project that we started under the Roasted Root organization. And basically, this is a fork of the JDBC driver written by Xerial originally for connecting SQLite to Java application. SQLite is an extremely well-known and used database. They claim that is the most used in the world because it's used in every Android application and every other device, and is a C program. And what happened is that we are building SQLite from the source code, so from the real distribution of it, using WASI SDK, which helps us to compile a C program into a WASM binary. Once we have a WASM binary, we use the Chicory AOT or the Chicory compiler. And basically what happens is that the WebAssembly code becomes Java bytecode. We are translating WebAssembly operations into Java bytecode instructions. This becomes extremely fast on the JVM because you take advantage of all the good parts of the JVM, as we already mentioned, and remains and you don't need to access external resources with JNI or foreign function interface. So you are never leaving the JVM actually. So for portability, since everything is completely self-contained, there is no limit to it. It's just bytecode that you are distributing as any other bytecode. For safety as well, everything remains inside the JVM, and you can even monitor the calls inside the database, which is extremely fun. And yes, of course, this is just bytecode, so it can compile back to native image. Using native image, it can compile back to native code out of the box with zero configuration. And how you do it is extremely easy, how you use it, because you just have to change your dependency on the Quarkus JDBC driver to use SQLite 4J. And once you are running it, there is no observable difference than in your normal CRUD applications with Quarkus. So I can say orange and save it and maybe edit something. And at the end of the day, is the very same behavior but in this case, we have SQLite, which is running in pure JVM.
So yeah, no, and this is like one of the fun part because for many years H2, like a pure Java database, has been a thing people use, but some people love it, some people don't like it. And SQLite is one of those, said, like, it's massively used everywhere, especially in like edge or like on device executions. And I like it because the binary becomes smaller. I don't have to rely on a binary for Mac, for Linux, for
this is actually 500 kilobyte package that you can run on any JVM without us having to do anything specific for the target. So you can run even on JVM that runs on embedded systems or with heavy limitations, and there is no problem for us.
Is there other libraries like this, like other than SQLite 4J, that like any other examples than
Hiram, do you want to show ProxyWASM?
Yeah, let's see. Do I have to share? How about you just pull it up on your screen?
Yes, I do.
Yeah. So there's a WASM standard out there that got basically started by the Envoy folks called Proxy-WASM. And it describes an interface for how a proxy like Envoy can use plugins written in any language, because that's their thing. They wanted to be able to bring in HTTP filtering type logic into the Envoy proxy. So they defined this Proxy-WASM standard. It's been adopted by a whole bunch of different proxies. I think there might be an Nginx one. They can load ProxyWASM. Definitely the Higress proxy from Alibaba is basically making that, using the ProxyWASM interface, their main accessibility point. Like basically all their extensions and all the features that they build into the Higress proxy is based all on ProxyWASM plugins. They got a huge catalog, a whole bunch of AI related features and stuff that are all implemented as ProxyWASM filters and stuff. But anyways, idea being is, hey, so how can we use some of this WASM goodness from Java? I thought, oh, there's this nice little spec called Proxy-WASM. It might be nice if basically any Java program, like any JAX-RS app, can just use one of the existing Proxy-WASMs that are out there in the wild, right? So maybe go into, for example, actually go to the Quarkus Proxy-WASM repo. It's I guess you could just search for it in the Quarkus catalog for ProxyWASM. It should be there somewhere there. There it is. Cool. And maybe go into like the integrations. Yeah, I got some. Go into maybe that's a good one. So the Coraza web application firewall is it's a really big plugin that basically does like threat detection to see.
Oh, did we lose Hiram?
Yeah, I was wondering if it was just me, but.
Oh,
So they got a huge database stuff, and they've compiled it to a WASM plugin meant to be run inside of inside of Envoy. But now we can take that and basically run it as a JAX-RS filter for any Java application. So if you go into that example, to the source, maybe go into the main. Okay, we can do the test resources. I was just going to show the main real quick, so we could see. Yeah, that's an app. So there's where we basically show how to load the plugin at the bottom.
Can you zoom in, Andrea?
Yeah.
Just it's a bit tiny here.
So this is basically how you build it. We're creating a plugin factory in there, and we're just going to produce it like with a CDI annotation so that we can load it up later. We name it just WAF. You can give it any name you want. And the rest of the stuff is like how we load it. The course, that machine factory is basically how that's the thing that the bytecodes that get generated from the WASM. So we have a build step which generates that class right there. And so that's how we load it in. Basically, shared basically means we're going to have one instance that we share across multiple threads because this plugin is actually pretty slow to start. So I don't want to, if you said shared faults, basically we would create one instance of the plugin for every web request coming in to avoid locking. But right now we're going to have locking between them because it's like slow to start. You can set a logger so you can capture the standard output from the plugin. And then the other thing is we pass it a configuration. That config gets loaded from right there real quick. It's just a string that we read it from the resource. And that's just the standard Coraza web application firewall config, which you can go to the Coraza website to see, hey, what does that config look like and handle it. So basically we generate this, and then there's another annotation that we put on resources. So if you pop back out into the directory where that example is, go into, I'm sorry. Yeah, you got to go back into where, go back real quick.
Oh,
yeah, go back to where that app was.
this is web.
I think we lost Hiram again.
Okay.
Yeah, he's looking a bit frozen.
We have some delay on you sometimes.
Yeah. So click on that example directory, the one that's holding that app.java.
Example. Oh,
yeah, there you go. Boom. So I think we have the anything. I think that might be a resource. I think maybe. Yeah. So that's a regular JAX-RS resource file, and that's how you enable it. Basically, it says any of these methods in this JAX-RS resource file, like we're going to filter it with the web app, the WAF filter. And that'll intercept all the HTTP requests and responses and be looking at them and see if it's like a potential security risk. And that's all there is to integrating, or at least using this. you know.
Yeah. How's it? So you got that? Forgot the Quarkus. It must be written somewhere in the build somehow.
Oh yeah, sure.
How does
Like,
that?
let's look at the POM that builds this little app. Yeah, right there. Boom.
Yeah.
If you look at the POM, you go down there. There's going to be a little AOT plugin. Basically, you point it at the WASM file and you tell it which file, like which class to generate, and so that'll generate that Quarkus class, which is what we use to load all the bytecode out of that WASM file. And since we're like building this at runtime, it's very fast to like load up. We don't like Chicory also supports doing this exact same thing at runtime. So you don't have to do it at the build time. You can just point it like at some WASM when you're starting up. But of course, now you're paying the price of compiling that to bytecode during runtime. And it's using reflection, so then you can't use it for native code. So by doing this in a build step, then you can also kind of turn all this stuff into native code too if you want to.
And the name here, org example internal, that cost about that's
something you define. You can put this whatever package you want to put this in.
Okay, yeah. So it's not just a name; it's the little base class name of the where things gets to be. Yeah. Okay.
Yeah.
Cool.
And we have more integration that we are doing. If you want to look at something more bleeding edge, in the sense that we are.
Oh wait. So wait. I think so. Just before we go to the next one.
Go.
Because I'm here. Because I actually missed this part. That there was like a whole ecosystem of this ProxyWASM stuff. So these, how generic are they? You said like SQL injection. That must be some.
Yeah, like
these.
Basically, Envoy made them super popular, right? Because it's like to extend Envoy is kind of hard, right? They've started getting better at it. They started supporting using Go to extend Envoy and stuff, but for a while it was Proxy-WASM was the main way people could basically take any language to extend it. So it became kind of popular. And of course, there's always people just have their little one-offs. For my company, I have this one specific need. I want to filter on this header, and when this header's this, then do that. You know what I'm saying? But there have been some, some bigger packages like this Quarkus one. There's the Quadrant folks are, of course, building all their API management, filtering stuff using WASM too. So like we have an example in here that basically use Quadrant to do rate limiting. So basically, if you want to rate limit your Java calls, you put in the Quadrant filter in it, and it'll basically intercept every call and check against limited order to see if you have any requests left, and then if you do, it'll pass it through. So that's in there. The Highgrass is one of the biggest catalogs of WASM filters I've ever seen. It's like if you go to the Highgrass catalog of like plugins, it's like at least 50 or 60 plugins I think I've seen. And I've started creating I just started a project that started trying to make it easier to wrap all the Highgrass plugins. I've got 2 of them. That's all. Those are all. They implement C++. They have basically 3 styles of they implement stuff in. They do it either in Go, C++, or Rust. Most of them are in Go because, of course, Go plugins are so much easier, right?
All right. Yeah, like the geolocation or other.
They got AI rate limiting. They got all kinds of stuff.
Pretty cool. Yeah. Oh, yeah. And for those who don't know, like this became available like a few weeks ago, right? You had the source, but we put it on Quarkus.
Yeah, and the main thing is like the reason I'm presenting here is like I just wanted to be known it's out there. Like, this wasn't a possibility before to just run off the shelf WASM filters. Now it is. If you guys find use of it, let me know. We can improve this.
Basically, you go to Higress and you can where do you find the WASM file? That's the thing.
Oh, you have to compile it. Okay, so if you go back to roasted root, Andrea, I started a new little project that makes it easy to convert those plugins into Java ones. Yeah, you just go to the top level roasted root. There's a new repo in there. It's Higress for J that I just committed it like 3 days ago. And for example, there's like basically like you can click on one of those whichever project, like GeoIP, whatever. And if you go into the POM, go to POM XML real quick, just to show real quick what's going on in there. It does a Maven step where it basically says, hey, run this build.sh first. So that's the one that actually, once the WASM file is generated, but the step before it basically creates that WASM file. It runs build.sh, giving some arguments. Hey, I want this plugin GRP. So if you look at the root of build.sh, basically it sets up, basically it uses Docker to basically check out the Higress stuff and run the build for you for just that one plugin. You see what I'm saying?
Yeah. All right. So there's still this. It's not like people. So wait. So why doesn't these WASM file already exist?
Because so they build it and then it becomes part of their product, right? Their product has all the WASM files in it. You see what I'm saying?
Yeah.
I'd have to download it, unpack that, all that kind of stuff, and I just want to build it from source because I just want this like one or two, and basically we just package it up as a jar because it's all bytecode now. The WASM file went away, like it disappears, and it's all bytecode after this.
Yeah.
There is also an optimization which we are doing, is the fact that once we have translated the WASM code to Java bytecode, we don't need any more the function bodies, which is the biggest part of a WebAssembly file usually. So we strip them down, and we just keep the metadata to let you load very fast and very efficiently just the metadata of your
that's after you get the WASM file, then you compile it to Java bytecode, which then is optimized, right?
You know what's funny is the jar files are smaller than the WASM files after you compile them.
Yeah. No, but this is the thing. I'm just trying to get my head around. Like, there's this Higress, there's this catalog you talk about, and there's other Envoy stuff. It's why I'm like, where's the WASM Maven repository? Like, where's the catalog of WASM? But basically,
I do think that people are trying to come up with something like sticking WASM in OCI repos and shit like that, but that's not a standard yet, right, Andrea?
Yeah, we don't. There is no widely used standard for it.
Yeah.
So it's like shipping jars. So you don't want your jars to stay in your repository.
Yeah.
Usually, and that's the reason why we don't commit the WebAssembly files usually.
No, I'm saying, like, there should be a repository of it, like with a unique ID. Like, here's the what was that? GeoIP.
Like WASM Hub.
Yeah. So
is a compiled artifact. So as any compiled artifact, you might want to tweak how it is compiled and the information that it contains, etc. But yeah.
Okay, well, so then if that's the case, then I guess you're taking some choices in that creation WASM file here in your HK proxy thing.
So I think a lot of this could be legacy, that a lot of the projects that are compiling to WASM are traditional, like native C, Rust kind of projects. And they've never taken their output and like created like they've never compiled stuff in libraries they just post to, like we do, like with jars, because we have stuff that you write once, run everywhere. So it makes sense you take the output and just post it so people can reuse it. You know what I'm saying? Whereas in native, you can never reuse the binaries easily across platforms. So, I think there's still a little bit of that mindset that it's like, oh, we got this WASM thing. It's reusable. You know what I mean? Yeah.
Well, that was I'm surprised it doesn't kind of exist. So yeah, cool. Actually, we had a few questions before we get to the next one. Like, does it support host functions? Does the inner code bytecode be redistributed? I guess the last one you already answered. Yes, you can.
Yeah.
But
Emmanuel, you know what we're talking about. Yes and yes. It's extremely easy to use host function and to define host function to be used by the WebAssembly module.
maybe explain what host function is, because not everyone has the terminology right here.
I was just about to ask the same thing.
Yeah.
So host functions are functions that are defined in Java, and they might be used by the plugin. So on the WebAssembly side, so by Rust code, C code, JavaScript code, whatever. So you define some function in Java that is our primary programming language, so it's extremely easy, and you just expose those to the program so that it does have access to all the sandboxed resources that it doesn't normally have access to. So you can, for example, show some part of the hard drive or the file system, or you can connect the sockets or do HTTP requests. And this is all done by providing host functions to your sandbox. And there are some standard ones which are part of the WASM specification, which is the system interface, and give you some possibilities over capabilities that you normally want to use. For example, reading arguments from the command line, or reading environment variables, or those kind of things. And then you can provide even custom one. And the generated bytecode is just class files. So you redistribute it as a jar, and the WebAssembly module will be is just the Java code that is contained into the jar.
Do you have an example of how to expose? Because I guess it's
yes.
to expose and return something, or
so we can check SQLite. Here. Yes. So here, for example, you have those functions which are executed by the event handler of SQLite, which in this case, they are just handling some global state progress or doing some callback or freeing some resources. But those functions in this case are just plain Java functions that are called and invoked by the C program because they are available in it.
yeah, go ahead. I was just going to ask, how do you tell the
Here you go. So those are host functions. You have a namespace basically that defines where your host function should live. You have the name of the function itself, the list of the parameter that it accepts, and the list of values that it can return. WebAssembly has this peculiarity that can return multiple values. And then you have a lambda from instance, which is your actual WebAssembly instance which is running, and the arguments that are provided to the functions to run whatever Java you want in here.
Got it. And there's no. This doesn't feel well. This is cool, but it feels very manual. If I already know the instance.
Correct. This is very manual, and that's why we fully automated with annotations. So if you look at, we have a couple of sets of annotation which are called, which are on the host. And basically what happened is that you can implement your imports. So actually define what you are importing, and this let you implement the specific functions that are defined to be imported with plain Java signatures. And in this case, I'm implementing, for example, fd write, which is a very low-level primitive, but you can see that in this case, the signature is fully is just plain Java, and I have just had to annotate my class with a WASM module interface and implement the module imports. So with the module imports, I have already binding already generated for me to define those functions that I showed to you. And this is wrapped together with annotations, basically. At the same time, you have also exports that indicates the different entry points for your WASM module. So if you have a WASM module, which is a library, for example, you can invoke different functions on it to perform different things. And those things are all, and all the conversion are taken care of for you with the module exports, which are generated by this annotation.
Cool. So that that annotation, what is generating the test module underscore module imports?
The WASM module interface annotation is generating both module imports and module exports.
Ah, got it. Oh, okay.
It's imports and exports from the point of view of the WASM module.
Correct.
So basically,
okay. So the WASM model, okay. So the WASM model already says, "Hey, I need these interfaces to be available. Give it to me." Okay. Yeah. But I was thinking the other way. Well, I guess in a sense, I was thinking, yeah. Okay. Yes. So yeah, because the WASM has to declare it first. It can't be. It's not like it comes up randomly. Hey, I need to call a random method on this one. No. Yeah. It has to be in the WASM declaration. Cool.
Correct.
Okay. Gotcha. Okay. We had one more. I think we did. You didn't answer that one, right? The memory allocation work. Yeah. How is this working with bytecode running on a JVM in that transformation? Is it allocating on the heap or like a JNI application? Well,
currently, is fully allocated on the heap. We have two implementation of the memory that are available in the runtime package at the moment, and one is based on byte buffer, and the other one is just based on a byte array. So you have full control of it. Those are just streamlined implementations that help you to get started with anything, but you are free to rewrite, and is extremely easy. So at the end of the day,
so the data is on the heap, but it's not shared with the JVM, right?
It is shared with the JVM.
Oh yeah,
is a byte array into
yes, you can think of this as doing this. When we transform the WASM into Java bytecode, that Java bytecode is just doing a whole bunch of operations against a big byte array that's a memory.
Yeah.
And it's just modifying. It's like reading it, it's going to go over here to this offset in the byte array and read four bytes.
Yeah.
Get that value. So that's all it's
I can't. So what I to it. So this is what I'm saying. It's a sandbox byte array, right? Like if I have an instance, I have an object, I can't pass that into the Chicory WASM thing and have it call on me unless I give it some host functions, right? Like it's
correct.
So,
correct.
The only sharing of memory is via the host functions. Right.
You can read and write the instance memory during runtime.
So like Java could act like a debugger on that byte array memory. And you could read it and modify it behind the back of the WASM.
Yeah. So because I know, for example, this is like again, this is coming from my GrowJS truffle stuff, right? Like they have this representation of data that is separate. So when you go from Python to Java, there's always this like not direct serialization, but there is some back and forth, and I guess the same thing happens here in WASM. Right?
Yes, that's correct. To keep the sandboxed, and do not have to deal. You have a very specific memory area which is dedicated to take care of those things. And what you've been talking about is also implemented, and we are still iterating, but this is early as well. But
the QuickJS thing,
we have QuickJS, so we can run actually QuickJS. QuickJS is a JavaScript runtime which implements which is compatible with most of the standard and is used in production by big and very large companies like Shopify in their WASM functions, but is a pure runtime, so it doesn't expose to you the browser API nor the Node API. So you don't have access to things that are security sensitive, and you have to expose those things explicitly to your JavaScript environment. That's why we have those things where you can provide built-ins, which means that is something that will be available for you into the JavaScript scope. So here you can actually write plain JavaScript, even invoking the functions that you defined in Java up here. And then we have easier annotations to make this very easy to do. Like with this, we are experimenting with this script interface, which is extremely cool, so that you can actually, at the end of the day, just invoke stuffs on top of the JavaScript library and have all the functions already binded for you with all the forth and back that is taking care for you.
Just to make sure, so QuickJS is implemented in Rust or
C.
Go or C.
C and Rust.
Yeah.
And there is a tiny wrapper in Rust.
Yeah. You did the same thing as you did with SQLite. You compile that library or that binary into WASM, and then you basically get the engine, and then now you just added some syntactic sugar to bind it to the chicory Java
Yes, in this case, we are using the same plugin as Shopify is doing as the base plugin. So this is Javi, which is like the standard that they are using in Shopify infrastructure.
So I'll ask a question which I know was placed on Quarkus Dev a week or two ago. Like, why are you doing this JavaScript thing? Why not just use the GrowJS thing? What's the difference here? Can you?
Yeah, so GrowJS has a very different objective than QuickJS for J. So GrowJS aim to be a node substitute. So you can take your node applications and get them to run on the server side directly on GrowJS without any modification. We don't aim to do it because the node API is pretty powerful and access sockets and threads and does a lot of stuff on your system. And we don't. And for letting you write the plugin, those are security holes that we don't want to expose to our user. Instead, what happens is that we just want to give the minimum amount of functions to let people write a JavaScript plugin in their own language. Moreover, here everything is being run in pure Java. Again, so there is no access to any native system library, nor to nothing that is system-wide. So everything is just running in pure Java with all the monitoring, all the checks, and all the observability that you normally have.
Yeah,
so
and
you get better portability, right? You can run
as
on
well.
any JVM.
Yes.
And you also don't get like one of the like again, we talk versus threads in Java. Like one of the challenges is native. You run native code. You can pin the thread and pin the carrier thread. That doesn't happen here either, right? Like it's pure bytecode, so therefore you should be fine.
This is pure bytecode, and I have not experimented widely with fibers and threading in this case, but it should be perfectly possible to just spin one environment per thread or per virtual thread and just run JavaScript in there. That's totally doable, and there should be no problem.
This is so I'm trying to see if there's a way to explain, because this is the thing we are talking about here is using another language as a plugin language to the JVM, where GrowJS is more about, hey, take any existing stuff out there, whether it's Python or Java, and run on the JVM with the advantages and disadvantages that are there. Like both use cases have a reason to exist, and they might sound like doing the same thing, but they're not really, right? So that's I think important for you to realize.
Well, there's a dog party somewhere.
Yeah. Okay. So we had we talked about SQLite for J. We talked about Proxy-WASM. We talked about QuickJS for J. We had something about Debezium in the abstract. Was that just that they are using it, or is there anything more?
Yes. So Debezium is a change data capture. I think almost anyone here knows about it. And the cool part is that this is deployed very. My dog is barking. And
yeah.
And the cool part is that Debezium is deployed usually in Kubernetes environment and in a lot of cloud native environments. And what happened is that most of the people having to do something with Kubernetes environments, they are Go developers, and they are used to actually use and write Go applications. That's why, for example, in Debezium, we have enabled filters and routers to be written like simple message transformation in Go. In this case, the cool part is the fact that you don't have to. We are not taking care of serializing for you the content of the message, because that will be very, very heavy for every plugin. But we are exposing an API that let you get to the specific fields of the message that has been deserialized only in the Java memory, and you can access specific fields and check against them and do the minimal work, so that you don't have a lot of data crossing the boundaries and being heavy on the hot path of your application, of your Debezium.
So the use case here is they use Debezium's capability to do the listen to all the database and the data events coming in,
yeah.
And then you can use your favorite language in processing it, and then off you go. Yeah. So this is a case of, let's see if I can do the lingo correctly. So Debezium can have WASM-based plugins, and Debezium adds a host function called Debezium that has these things that they can call. Do I capture it correctly, or?
This is a PDK, what we call a PDK, so a plugin development kit. So it's kind of the SDK that you give to the user to be using your host functions. And yes, we call it Debezium just to refer that you are calling something into Debezium.
Yeah. Cool. Okay. Awesome. Any other examples of applying this? It's all turtles all the way down, basically.
I don't know. Let me see if this works still.
And can you also talk a bit about performance, Andrea or Hiram? Because you mentioned that the jar files are smaller, but do they?
I don't know why. Do you know why they're smaller? Is it just because we compress them in jars? Like, I don't know, but it's just cool, I think.
Let me see.
Maybe bytecode's more compact than WASM opcodes.
Well, is WASM a jar in itself, or is it like a raw binary?
I think it's not compressed, right, Andrea? It's just raw binary.
Yeah.
Yes, is a raw banner. Yeah, but anyhow, regarding performance, I think so. We are comparing directly against the GrowJS. They have an implementation of a JavaScript of a WebAssembly runtime in Graal, and we are competitive with them, especially with the compiled code. We are not really far, so you have to expect Java-like performance. So very much Java-like performance. It will be just plain Java code running on your application.
And this brings back memories. So.
Yeah, you can run whatever. I mean,
well, there's two kind of performance. What you're talking about is like the execution of raw WASM. Their Chicory with the bytecode, the approach is on par with, for example, what you see with GrowJS. But I think the one that's a bit more interesting is like you compile SQLite down to WASM.
Yep.
How fast is that compared to native?
So I have not been running benchmarks. There is a similar project in Go which is compiling and running SQLite on WAS0, and its performance are comparable with native. But they did a lot of work to make it really fast. Is achievable. It depends on how much you want to take from the standard things that are out of the box and available just to anyone, and how much you want to dig
I think what we're saying, I'm saying, I'm not trying to put you on the spot here, but when I heard you talk about it, it's like, yes, we haven't measured the performance of SQLite, but we expect it to be having some impact, but not like, it's not like it's unusable. Maybe like 5, 10, 15% or something. It's within.
Yeah, you got to think the runtime has to basically implement like instruction optimizations that like a C compiler can do. The WASM opcodes are simpler, just like bytecode opcodes are simpler. But then it's up to the JITs to figure out how to optimize those opcodes to be faster. Yes. So if the Java JIT is optimizing our WASM bytecodes properly, we can get close.
Yeah, right. So, and that's the thing is like, so that's what in most cases this should be fine, but you could imagine there will be some like very hot spot that the WASM code doesn't get translated over effectively, and then it triggers something. But that would be a special case probably. So,
on average, you might expect some slowdown. But for example, like with the recent changes, there is this project which is taking containers and compiling them to WebAssembly. And in this case, an Ubuntu container with recent changes is taking at the moment like 30 seconds to boot and run the first application like Eco or whatever. Yeah. So we have been working toward it, and it is still 30 seconds, which is slow, but we expect to make those things available with improvements.
I forgot that one is really what I mind bending, right? Because so think about it. This is just, I want to repeat for those who might not get it. This is you taking an arbitrary Linux container,
correct,
compile that over to WASM, which basically means anything. So that runtime can run Java. Like, can could you take a Docker container with Java in and run it via to WASM and then run it in Chicory on your JVM, right? Like this is like a whole, like, yeah. And that becomes super interesting, right? Because then you have, well, I'm not saying super interesting, but it becomes like, the ultimate performance test, but also becomes like, hey, what's so special about containers anyway? It can run. You can basically take any Docker container and run in a JVM, which is weird.
Yes, I'm not sure this is the primary use case for it.
No, I know.
But you usually do containers not only for having one single executable, let me say, but also for putting into it whatever it comes from the internet,
and now,
not for integration.
And you guys got to remember, what this is doing is using QEMU, right? So it's emulating. My internet's been flaky. Yeah. So you got to remember, this is you do an emulation. So it's emulating. That's why it's a little slow too.
Sure.
Right?
Yep. It's basically treating containers as a Python app.
Exactly.
Yes.
Hey,
performance could get better though. I mean, it would be so cool for dev services in Quarkus to sort of have a restriction-free way of running dev services.
Oh, I hadn't thought about that. Yeah, you could run the key cloak. Let's take something else. Like, yeah, you can take a one. Yeah. Oh, I hadn't thought about that. Hey, that's actually cool. Yeah.
Yeah. So you can do it like where you have a custom one. You can do it for the custom one, and then when you don't have a custom one, you can just run the container.
Yeah, because that's one of the things. Oh, man, Andrea, we should try this just for fun. Because what, like in Quarkus we have dev services, which is great if you have Docker or Podman on your machine, but there are some enterprises that doesn't allow that. They probably will also not allow us to run any arbitrary container in Java, but
but they might be able to stop it.
Yeah, but in this case, you're literally you could have this distributed and run it through that way. But yeah, it'll be interesting to take. If it takes 30 seconds to boot up, then it's probably not a big, not a good thing. But yeah, so
it's probably we are probably not there yet for the usability that you want for dev services. But we will eventually get there. But and it is definitely usable for tools. So if you do have a specific tool that you want to run in your dev service, or if you have a specific application and maybe it can be compiled to WebAssembly, you can directly run it without having to bring along all the container. So it might we have also to see the list of dev services, and maybe something that just applies out of the box.
But so I'm just being a bit weird or crazy here. It's like I'm thinking about, like, for example, like brew install on Mac or SDK man on something. Like why don't we? What's stopping us from creating? Let's call it the Chicory man, Chickman, that has a repository of pre-built tools that just runs on a WASM runtime. What's the blocker?
No. There is no blocker, no real blocker, in the sense that they have been doing it. There is an effort on a repository called the WASI-libs on top of WASIR for just repackaging all standard application like a Proto-C, etc., into Go packages that are just out of the box Go packages. That is the same that we can do with Chicory. So WebAssembly, this is kind of an edge use case of a WebAssembly, because WebAssembly has been defined to do embedded systems. So to take some programs, expose to it some functionalities, and use it in your application. In this case, we are just reusing a CLI, which is a nice side effect of being able to run it with WebAssembly, but is definitely not the target use case for it, or not the primary target use case for WebAssembly.
I think that use case would be more interesting to users that are weird platforms. Right?
Yes.
Like if you're on one of the primary platforms and it's like, I'm just going to get the native version. Like, why would I go through the trouble of all this kind of stuff? But if you're on some crazy risk machine or something like, I don't know, like the mainframe or some crazy thing, you know what I'm saying? Like, oh, something like that could be cool because nobody's targeting you, you know?
Yeah. So
Actually, in jQuery itself, we use some tools for dealing with, for example, text format. We don't have a text format so we are not able to parse WAT files at the moment. So the text format of WebAssembly, we just parse the binary format. But what we do is we package C++ and Rust applications that are able to read the WebAssembly text format and then meet the binary format. So we automatically reuse C++ and Rust libraries for doing it inside our CI, and it's completely portable. We just added the support for all the ARM machines that are available on GitHub Actions, just automatically.
Yeah, and similarly, there was this problem where like I wanted to read the debug symbols out of WebAssembly modules, but it's in a dwarf format, which is crazy hard to parse and understand. So it's like, but there's a library in Rust for that.
Yeah.
So I just use that. I put a whole bunch of JSON that's really easy to understand, and I call that from Java to just get all that out. So it's like, I think there are some lots of specific tooling use cases that this could be really like. I don't want to redo this in Java, but there's something that exists. Let's just use that. You know?
It's a whole different. It opens up the instant world. So, and one thing and maybe we talked about this before, I just forgot. But in like the whole, you heard about a thing called AI that people are doing. Like, there's some native libraries in there, like Onyx and stuff, that are implemented, and they are currently a native binary that we have loaded. And I'm like, maybe we could wasify those. And there we could be very easy, like just compare the performance. Would be interesting. So yeah, that's definitely stuff to explore here.
And I feel like if you looked at the like if you were calling into a JNI library versus calling this, it will perform better because you're avoiding the JNI barrier, which basically sometimes does memory locking and garbage collections like stuff and all this kind of stuff, where this is all staying inside the Java heap. So like,
I guess with the I hear you, but I guess with the what's it called, the new Java foreign function, that goes away. But with foreign function, you still have to have a binary in your OS specific format.
Yeah.
But with WASM, you get this thing, and it seems
plus, because then you have to compile it for every platform and package them and redistribute. You know, it's a whole mess. Yeah.
So and that there's something here like that could be really, really interesting. For like, I'm just looking at like I guess like JLine. For like JLine has a native access to the. Well, I guess it's needed to talk to the OS, so that's not a
OS functions. Yeah. That's the one thing you still need really. Like when you're accessing OS syscalls and stuff like that.
Yeah, so the use case is more these like actual true libraries like NumPy or Onyx execution or something. Yeah, that'd be cool. Anyway, we over time. This is like. I already like WASM, but now I'm even more keen on doing more. And the Proxy-WASM, I knew that what it was doing, and I was like, hey, this is cool. That's a nice idea we can do. But I didn't understand there's like a whole library of reusable stuff. That one is different than anything. So yeah. Any last minutes thoughts or comments? Yeah. All good. Awesome. And what was the GitHub repository? The roasted chicken? No, roasted what?
Roasted. I sent a link in the chat.
Roasted root was the thing. Yeah. So anyway, for those who are interested in this, go to roasted root on GitHub or on the Quarkus WASM proxy. And we'll go for that. Cool. let's keep it at that then. And yeah, thank you.
Thanks, all. See you.
See you guys.